Have you ever wondered why time seems to fly when you're having fun, but drag when you're bored? Or why a long-distance journey seems to take forever, but the return trip feels much shorter? These are everyday examples of how our perception of time can vary. But what if I told you that time and space are not as fixed as we think they are? Would you believe me? Welcome to the intriguing world of the special theory of relativity, a theory that completely revolutionized how we understand the universe. Invented by Albert Einstein in the early 20th century, this theory states that time and space are not separate entities but are interwoven into a four-dimensional fabric called space-time. But what does this mean? Let's break it down. Imagine you're standing still. To you, time seems to be passing normally. But if you were moving at the speed of light, time would appear to slow down. This is known as time dilation. And it's not just time that's affected, space is also impacted by speed. The faster you move, the shorter the distance you'd perceive. This is referred to as length contraction. These two phenomena, time dilation and length contraction, are key aspects of the special theory of relativity. They suggest that time and space are not absolute, but are relative to the observer's frame of reference or speed. And this brings us to another crucial point of the theory, the speed of light. According to Einstein, the speed of light is the only constant in the universe. It's always approximately 671 million miles per hour, regardless of the observer's speed or direction. This is a fundamental shift from the Newtonian idea of absolute space and time. It implies that the universe is not as fixed and deterministic as we once thought it was. Instead, it's a lot more flexible and dynamic, always adjusting to the observer's viewpoint. So, to recap, the special theory of relativity tells us three major things. 1. Time and space are not separate but are part of a four-dimensional fabric called space-time. 1. Time dilation and length contraction occur when an object moves at a high speed, suggesting that time and space are relative and not absolute. 1. The speed of light is constant, regardless of the observer's speed or direction. These ideas have transformed our understanding of the universe. They've shown us that time and space are not as rigid and unchangeable as we once believed. They've also paved the way for many scientific advancements, from GPS technology to particle accelerators. So, next time you're wondering why time seems to fly or drag, remember that it's all relative. After all, in the grand scheme of the universe, we're all just moving at our own pace. And who knows, perhaps one day we'll be able to manipulate time and space to our advantage. Until then, let's keep exploring and questioning the mysteries of the universe. Because as Einstein himself said, the important thing is not to stop questioning. Curiosity has its own reason for existence.